In this experiment, I'm going to investigate what affects whether something floats or sinks in water. So I'm going to start off with 4 identical tubes, but with different amounts of sand in there, so different weights. We're going to investigate the effect that the weight might have on whether something floats or sinks. So if I put this test tube in with no sand, then it very clearly floats. I've got this test tube here, and this has got about 1/3 full with sand. And if I put it in, again, it floats. So it's just bobbing around on the top of the water. This one here is 2/3 full. And again, it floats, but much lower than these two. And then finally, this one is full of sand. And if I put this in there, then it sinks to the bottom. So you can see that this one, which is floating about here, this one is sinking to almost to the cap, and this one is sunk, is that the bigger the mass, the less likely it is, or the lower it floats. So the more mass inside it, the bigger the weight pulling downwards, the more upthrust is needed on the tube, the buoyancy force. So in this one, we have the weight pushing downwards, and the upthrust is just about enough to hold it upright. Now, we wonder whether the shape of the container might make any difference, because these are tall and thin. So we can have a look at these containers, they're slightly bigger, and see whether that affects it. So again, this one is empty and very clearly floats. This one, about 1/3 full, and again, floats. This one, about 2/3 full, and it just about floats, very similar to this one. So the shape does not seem to make a difference. If I put the full one in, it sinks to the bottom. So the shape of the container doesn't make a difference to whether it floats or sinks. We're just going to have a look at the volume. So we're going to start off this tube here, this container here, and this container all contain roughly the same mass of sand. So if I put this one in here, then it sinks to the bottom. This one here is a bigger volume but the same mass, and so it floats. The mass, the weight pulling downwards, is still the same as the first one, but the upthrust, because this is a bigger container, the upthrust is bigger because the pressure acting on the container is bigger. It's a bigger volume. Finally, we take this very large container and we place it in there, and it clearly floats quite high. So it's a bigger volume again, so therefore the upthrust is much bigger than this one, and much bigger than the one that's sunk. So in this last experiment, I've just taken a piece of plasticine, and in one case I've spread it out to make a bowl shape. So this is a solid ball, and I place it inside and it sinks to the bottom. Whereas this one is a bowl shape. So although the mass of plasticine is the same, because I've spread it out now, it's got quite a lot of air inside this bowl as well. So overall, the density of this is much smaller. Also, because it's a bigger volume, there is more pressure. So the water will be pushing up on a bigger surface area, and therefore the pressure will be enough to support the bowl. So if I place it in the water, you can see that unlike the round one, it floats. So overall, the upthrust is equal to the weight, and it's supported floating. And in this container, you can look at it, first of all, in terms of the pressure. So there's a much bigger area for the water to push up on. So therefore the pressure is changed. Or you could also say that the density of this, because it now contains a lot of air inside the bowl, is much lower than the density of this round one, because that is solid.